Today we are see the new spectroscopic tool, that is a Mossbauer Spectroscopy. I am Dr. S.P. Deshmukh, Department of Chemistry, Dayanand College of Arts and Science, Solapur. First of all, we aware about what it mean by Mossbauer effect and who has discovered this Mossbauer effect. Rudolf Ludwig Mossbauer, who discovered this effect in 1957 during his PhD work. Actually, this effect tells us how there is a recoil-free transition playing crucial role for the absorption of gamma radiation. Generally, so whatever the emitted photon which has exact frequency which corresponds to transition between nuclear ground state and excited state, that resonance phenomena leads to the Mossbauer spectroscopy. Then we see how there are different elements playing Mossbauer isotopes. So whatever the elements shown in the periodic table with the red font are different Mossbauer isotopes. Why? The elements which is having red font but having the black shaded portion indicate they are used in many times. So they are routinely used for the different elemental analysis. So many of them elements are used for this Mossbauer spectroscopy. Then the question arises, what it mean, the Mossbauer effect? Basically, it involves emission and absorption of gamma radiation with having atoms in the solid crystalline lattice, and this is the key factor for this spectroscopy. We have to aware about the NMRs which deals with the ground state. Why? This spectroscopy deals with the excited state and ground state of the nucleus. Then we have to aware about the different factor, or we call as a key parameters, in which first one is a radioactivity, then nuclear property, then Doppler effect, then recoil energy and nuclear resonant absorption. The question arises, what it means? Why we go for the radioactivity? Why we go for the nuclear property, Doppler effect and recoil energy? We see step by step. First of all, in case of radioactivity, this phenomena is based with having absorption of gamma radiation, and therefore cobalt is a major source which electron capture leads to de-excitation with having spin 5/2. But this is a highly unstable state. It comes to the ground state by de-excitation process with a spin 1/2, also 3/2. And from 3/2 to 1/2, that transitions with having the very less time, there is 100 nanoseconds, and they have to emit the gamma radiation. And that emitted gamma radiation was absorbed by the another nucleus. So how it is work? So this radioactivity phenomena playing major role for this spectroscopic tool. Then we have to aware about what are its characteristics. Generally, energy for that is a 10 to 200 kilo electron volt. These gamma emitters are having half-life time in many years. Why? It half-life in the range of some 10⁻⁶ to -10 seconds, and the decay process is nothing but the gamma radiation. So the question arises, what are the nuclear property playing major role to absorption of such type of gamma radiation by the nucleus? So in this case, we have to see the mass number, atomic number, the nucleus spin quantum number, and then with having respective example. The mass number with having odd, even or even. Atomic number also having possibility of odd even or odd. When there is a nuclear spin quantum number is a 0, the elements having cobalt C12, oxygen 16, they have not show the absorption, while the odd or even, they have to show the absorption of gamma radiation. So nuclear property playing major role to identify which elements are active and which elements are not active. Okay. Then we have to see what it means by Doppler effect. So whenever we go for the different spectroscopic technique, like to be IR spectroscopy, there is a modulation of the sources would be takes place. That is nothing but by using the grating. While in this spectroscopy, it modulate using the Doppler effect. So why there is a need of modulation? Modulations playing major role to give the particular frequency or wavelength of light, which can key cause for the absorption and emission. So there is a need of modulation in IR by using grating, while in Mossbauer using Doppler effect. How it is work? So we have to see this picture. In this case, if stationary source with having the sound, it gives to be stationary source gives to the proper sound. But when observer is moving toward the stationary source of sound, then there is a having positive shift, or there is a higher volume of the sound which we have to observe. While opposite for when observer is moving from this sound source, it used to be negative value. Negative in the sense their frequency of sound goes on decreasing. So that way there are two way of possibility. One is having positive, another one is having negative. And from that, what happened? This Doppler effect gives us the idea about that there is a proper resonance of the source and absorbers by modulation. So therefore Doppler effect playing major role for this spectroscopic tool. Then we have to see actually what it means by recoil energy and what is the recoil loss energy. Why we have to see this example? So whenever there is a absorption, there is also having emission. So we have to see the here first example in which the gun, where the bullet coming from that gun, and there is a having backward force that we call as a recoil on gun, that is a reverse force, and bullet moving in forward direction. So similar to that way, another example, a boy jumping from boat on water would fail to land on shore because energy deficiency rises from recoil of boat, because that boat move in backward direction. So similarly it would be happen in this spectroscopic tool. What happened actually? The gamma ray emitted from the nucleus would not be absorbed by the another nucleus due to this recoil reaction in its emission process. So it is not possible to occur the Mossbauer spectroscopy. This problem was identified Rudolf Mossbauer, and for that how he to overcome? So for that purpose again we see this example. So same boy jumping from boat but having frozen in ice, which can easily land on the shore. Due to its frozen, there is no recoil loss would be takes place, and that leads to the boy reach at the shore. So similar to this example, that whatever the loss of gamma radiation would takes place, that would be avoided, and that we call as a recoil free emission and absorption. Nuclear gamma ray leads to Mossbauer effect. And how it is avoided? For that purpose, that source would be embedded in the highly solid crystalline matrix, and therefore the loss of due to recoil would be reduces. So that way Mossbauer effect would work. Why we have to go for this phenomena? But while another spectroscopy, there is no need of such a solid matrix. The reason is recoil energy is very small than that of an emitted photon. So ER is very small than natural width in IR and UV. Therefore in IR and UV there is no need of such type of solid matrix to put that sample source. While in this case of Mossbauer spectroscopy, this recoil energy is very high than that of a natural line width, and therefore there is a need to put into the solid matrix. Then we see the fundamental principle of this Mossbauer spectroscopy. So this is the where there is a having non-resonant and there is a having resonance phenomena. So there is having the cobalt 57 to iron 57 and there spin 3 by 2 to 1 by 2, and during that whatever they emitted it reaches to what we call as at the this portion, and where there is a showing the resonance phenomena. So there is a source and absorbers that which leads to this is the fundamental principle of this spectroscopy. And what it mean by resonance? The energy of source which is equal to energy of sample. So sender which having the same frequency which is completely absorbed by the receiver. So that matching of exact frequency or wavelength leads to absorption phenomena. So source from ground state, nuclear excited state to ground state which emitted the frequency which is absorbed by the absorber in ground state and leads to excitation. So that phenomena gives us the resonance phenomena. Then question arises, why source and sample embedded into crystal matrix? I already told you that why it is required, because there is a recoil energy is reduced by the absorption of emitted gamma radiation. The absorption would be maximum if there is a recoil energy would be 0. If recoil energy is reduced by increasing mass, but it at how? The question would be answer with having placing that source and sample in the crystal matrix with having low temperature, because at a high temperature there is having thermal mode of vibration. At low temperature that mode of vibration would be less and there is a very less loss of recoil energy, and that recoil energy would be 0 in the solid matrix. So how it is we get the MB spectrum? So energy of gamma rays from source which is equal to the excitation of nucleus of sample. So source energy changes due to chemical environment with respect to sample. That another one, when we have to moving source relative to sample, then there is a show the absorption, and that absorption leads to spectrum. And it is also obtained that when source is fixed at a sample with having definite velocity and counting number of gamma ray passing through the sample, that we call as a frequency, and therefore we get the MB spectrum, that a relative transmission with respect to velocity in millimeter per second. So that way we get the MB spectrum. This instrument majorly work with having the source. There is having cobalt source which having emitted that radiation which can passes through the sample, and then then another there is having move toward the source and absorbers, and most commonly it is done by moving source toward the or away from the sample, and that way we get the how it is work. I thank you to all for this is the part first where we get the basic information of this MB spectroscopy. Thank you.